Today we will talk about the Pythagorean Theorem. First, we can only apply the Pythagorean Theorem when we have a right angle. So we're going to find the way to identify the different sides of a right triangle. So you should always see your right angle on a triangle, and to find the hypotenuse, which is the longest side of the right triangle, it's always opposite your right angle. So sometimes it's hard to find which one is the longest side, so you just find your right angle and then you go opposite, and that's your hypotenuse. The two other sides are called legs. So here you have leg 1 and leg 2, and they both connect to the right angle. So if you look at the second triangle, we have our right angle. So opposite here we have our hypotenuse, and then we have leg 1, and then we have leg 2 here. It doesn't matter which one is which, you have two different ones. And on the last triangle, again, you can see your right angle. Opposite is your hypotenuse. Then you have leg 1 and leg 2 that both touch your right angle. What does it look like, the Pythagorean theorem? You have a right angle, and you're going to have a side A here, a side B. It doesn't matter which one is which because they're both legs. So you have two legs here, and you have your hypotenuse, which is always opposite the right angle. If you look at A, the short side here, I have the same side here. A times A, this is going to be my A square. It's going to be the area of a square of length A. If you do the same with B, you have B times B, so this is going to be B square. So if you look at the picture on the right, you can see that this is my B square, and around here you have your A square that's spread around. So you can see that all of that is a big square that has a side C times C, so all of that is C square. So when we write it, we're going to write A square plus B square is equal to C square. We can also start with C squared and say, okay, my C square is equal to A square plus B square. As long as C, which is the longest side, is alone on its side. We're going to use the Pythagorean theorem to find the hypotenuse of a right triangle. So that's what we're looking for here. I'm going to call it X. So first we can write down our rule, which is A square plus B square is equal to C square. And then we're going to replace with the numbers or the values that we know. So remember that the two legs are the two sides connecting to the right angle, and that's my A and my B. It doesn't matter which one is which, so this is going to be A square plus 3 square, and that has to equal my hypotenuse, which is here X squared. And then you're going to calculate, so A square is 64, plus 3 square is 9, and that equals X squared. 64 plus 9, you can calculate that it equals 73. So this is my X squared. Now, if you remember, how do we get rid of a square? We have to do the opposite operation, which is square root. So I'm going to square root on this side and square root on this side. But here I'm going to get a positive and a negative value. Because if you remember, for example, minus 2 square is 4. And 2 square is 4. So we always have two values. Now here, my X, can it be negative? No. Okay, the negative part here is not working here because cannot work here because we have a side. Cannot be a side measure, right? So we're not going to use the negative part. So our answer is just going to be square root of 73. Now, we can take our calculator and we can find the value of square root of 73. So if you take your calculator, I'm just going to come here. You type square root of 73 on your calculator, you're going to get something approximately equal to 8.5 4 0 0, you get a few decimals. So which one is more fun to write? Is it better to write square root of 73 or 8.544 and so on? It's easier to write square root of 73 because it's really a exact value. Now sometimes they're going to ask you to round to the nearest 10 or the nearest 100. So we're going to come back to that later, how to round. If we want to find a leg of a right triangle, so if you look at the picture here, we have our right angle, we have our hypotenuse, and we're looking for this leg here who's touching our right angle. So first we can write our rule: a square plus b square is equal to c square. Then we're going to replace with the values that we know. We know c always has to be the longest side, so that's going to be our 25 squared. And it doesn't matter which way you're going to write your two legs, so I'm going to put it like this: x squared plus 13 squared. Then you can calculate what is 13 squared. Oops, sorry. 13 squared is 169, and 25 squared is 625. Now you want to find your x squared, so your 169, we need to get rid of that, so we're going to minus 169 on both sides. So here I'm going to minus 169 and then minus 169. Sorry. So I'm going to have x squared is equal to 625 minus 169, which is 456. And to get rid of my square, again, I'm going to square root on both sides. And don't forget your plus or minus. Again, the minus will not be used because the side cannot be a negative value. So we're going to eliminate the negative. Not good. Not possible. Okay, you can write something like that. And then square root of 456, if you type it on your calculator, it's going to be approximately 21.3541 and so on. So your answer would be square root of 456 meters. Okay, if they ask you to round, you can round to the nearest 10 or the nearest 100. So if you remember, the 10th is the first position after the decimal. So if they want you to round to the nearest 10, you would get 21.4 meters. And if they ask you to round to the nearest 100, you would get 21.35 meters. So those are options. Sometimes they will ask you to round. We can also work backward and check if a triangle is a right angle. So for example, do the following length form a right triangle? So imagine that we have a triangle. We're just going to sketch. We want to know here, is it a right angle? So for example, we have 40 here, 80 here, and 89. Does this form a right angle triangle? So what do we have to check? We have to check that 40 squared plus 80 squared is equal to 89 squared. So what we're going to do, we're going to put a question mark here. Is the left side equal to the right side? So if you type on your calculator 40 squared plus 80 squared, you should get 8,000. Is this equal to 89 squared, which is 7,921? So what you have to answer, okay, and you have to be precise in your answer. So do the following length form a right angle triangle? The answer is no, because 40 squared plus 80 squared does not equal to 89 squared. So I'm gonna ask you to pause the video and try the question B with 9, 40, and 41. Check if it's gonna work and make sure you answer with yes or no and explain why. So if you did it right, you should get yes, because 9 squared plus 40 squared is equal to 41 squared. Another question they could ask you, it's about Pythagorean triples. So those or sometimes they say triplets. To be a Pythagorean triple, you need 3 positive integers, a, b, c, such as a squared plus b squared equals c squared. If you remember, positive integers are the counting numbers. So let's check if 36, 77, and 85 is a Pythagorean triple. So first we're going to identify the longest side, which is the 85. So we have to check if 36 square plus 77 square, is this equal to 85 squared? Take your calculator, check 36 squared plus 77, you should get 7,225. Is this equal to 85 squared, which is 7,225? So your answer should be, you can write 36, 77, 85 is a Pythagorean triple, because 36, wait, I'm gonna add square plus 77 square is equal to 85 square. Hold on, I'm just gonna put the square with my pen. So 36 squared plus 77 squared is equal to 85 squared. Or we could write 36 exponent 2 plus 77 exponent 2 is equal to 85 exponent 2. That's another way of writing it. Online, that's what we're going to use sometimes when we want to say square. So pause the video, take a second to check if 5, 8, and 9 is a Pythagorean triple. And then you can start the video again to check if you're right. So you can check that 5 square plus 8 square is not equal to 9 square. So this is not a Pythagorean triple. Last thing we're going to be checking is how to solve problems when you want to use the Pythagorean theorem. So first, you should always draw a picture to place your known and unknown values, and then write your equations clearly. So let's look at this problem. MsLebel wants to fix a 2-meter vertical pole. So I'm going to draw my vertical pole, 2 meters. And how do I know it's vertical? It's 90 degrees with the ground. You want to place it with the rope that she placed 1 meter from the bottom of the pole. So that's 1 meter. And my rope, I'm going to put my rope in red. This is my rope here. So this is my X. Okay. And you have to round your answer to the nearest 100. So what I did, I put the place value chart just to remind you where is the nearest 100. So when you look at your picture, you should identify your longest side, which is your X. So you can start with your longest side if you want. Longest side equals 2 squared plus 1 squared. If you want, you can also write your rule to help you. Sorry, I should have started with that. A squared plus b squared. And so what you have to do then, you calculate 2 square is 4 plus 1 square is 1, so that equals 5. And then to get rid of your square root on both sides. And remember, when you square root here, it's going to give you plus or minus. Can we have a minus rope? So it's not possible here. So we're going to still write it, but we're going to write the negative and not possible. So my answer is equal to square root of 5. If you take your calculator and you calculate square root of 5, you're going to see that it's approximately equal to 2.2367 and so on. So if I want to cut to the nearest hundred, my hundredths position is here. I have 23 and there's a 6 after. So what's going to happen to my 3? It's going to move to the next digit after 3. So my answer is going to be, the question is, how long should the rope be? So let's write the rope should be 2.24 meter. Don't forget your unit, that's very important. Have fun practicing now.